CPU versus GPU. So one of the most frequently asked question, and asking us to explain brief at least how to see CPU versus like GPU. So we are trying to attempt in short way to understand basic concept of CPU versus like GPU. Okay. Hello everyone, thanks for joining with us in exploring a technology space. Welcome to Maths Bridge. Let's get into today's topic. In today's world, we are having some sort of a computer system. It could be a personal laptop, or it could be like a personal desktop and home uses, or professional systems. When you work, and we may have come across to see industrial computer systems like having a little more hardware powered systems, or gaming systems and all. So if you could actually visualize ourselves, right, these systems having a core processor, a microprocessor, what we can call it as a CPU, central processing unit, for basic understanding simplicity. So when you have a CPU, right, so CPUs are the kind of a processor, that's what we talk about, right? But how do you see CPU is like a brain of your computer. So it's everything, right? CPU stands for central processing unit. It is one of the component of a microprocessor, right, that plays a central role in arithmetic processing, arithmetic logic operations, ALU processing, in short. So along with the CPU in your computer system, you have other peripherals like input devices, output devices, and memory. Okay, I say main memory, but you have a RAM, ROM, cache memory, auxiliary memories like hard disk, and CD disk, flash disk, that short. So how these are all like interacting? So CPU interacts with input devices, CPU interacts with the output devices, CPU also interact with main memory, for computing user inputs and displaying an output. So you see, in general way, CPU is a part of your computer system. It is one of the component. We have a peripherals, we have a input memory. So that is how you can see it, for instance. So CPU is designed for general purpose tasks. That's why we say like this is general purpose, personal laptop uses, like running your operating system. It uses for browsing and word processing, etc. Okay, so if you look at a CPU has a cores, right? We have like two core processor, quad core processor. I think you might across hearing these words, right? So typically we see up to 16 cores in 32 cores, that short, but usually 4 to 16 for the most of the computers, to handle complex instructions in sequence. So CPU meant for general purpose, and also handles the instructions in sequence. Okay, that is the intent of CPU. I hope you get the point. Now let's look at a GPU. GPU means graphics processing unit. Here is a typical diagram. You have seen the CPU, how CPU interacts with like all other peripherals, right? Now we are adding extra unit called GPU, which is a in intermediate stage in between CPUs and your display units. When you would need to handle graphics and images, you need a dedicated processing unit, which renders all the graphics and imaging by rapid mathematical calculations, by performing rapid mathematical calculations. When we are dealing with a graphics and images, or 3D images, video processing, whatever it is, so you have a plenty of data, first thing, and then data in the nature of like a matrix. So computing matrix requires a lot of power, hardware powered. Then only you will be able to do things much faster, because which is what is required even pursuing on screen all these images in the real time, right? So how do you achieve this rendering of graphics and images through GPUs? GPU comes with plenty of cores. So when you have a course, more cores, then you will be able to do tasks in parallel. So these are the tiny cores basically. Like if you have a bigger task, the task can be subdivided into smaller, and these smaller tasks now handing over to a specialized course supplied by the GPU, and all this course handles these repeated small tasks simultaneously, and uh, produce the result in shorter time because the throughput is more if you have a more cores which handles tasks in parallel. Does it make sense? So GPU meant for a graphics processing unit, which we use to render the graphs, images, 3D images, video images, and AI/ML modeling and cryptocurrency mining, by performing rapid mathematical calculations. All right, so this is what the GPU means. Like whenever you see like a gaming laptops or high-end AI/ML modeling systems, that means that system you know uh, will also accommodate with GPUs along with CPUs. That's an idea. Let me give you a simple example and how you see CPU and GPU in simultaneously in simple sense. Like a CPU is like a manager. You act like a manager when you are actually playing a role called CPU, and you have a specialized folks like a GPUs, right? And then if you want to perform a certain task, and then what you do, you instruct a GPU and asking GPU to actually process that task, perform that task for you, right? You delegate that task to the GPU. So how do you do that? Like split the task into a smaller things, and then which are going to be handled by the GPU cores. Okay. When you say core, it reminds me one part, like when you are buying a laptop or a desktop or any system, industrial system, what do you see first thing is like what is a core processor, how many, what is a microprocessor speed, and then how many cores we have. Let's say dual core, quad core, hexa core, octa core, like so when you say dual core means like a two cores, the CPU has a two cores, each core can perform one task, let's say. So when you have two cores means like two tasks can perform can be performed simultaneously, right? A parallel, achieving a parallel processing by having more cores, right? So if you take that as an example, then GPUs have like a plenty of cores, thousands of cores, that the GPU is supplied with. In that case, you can parallelly perform those many tiny repeatable tasks by GPU. So that's the sense. So what we are saying is that when we are dealing with the image processing and graphics and all, a lot of data. These data need to be processed by in the system means a processing unit. The processing unit should be equipped enough with many cores. If you have many cores, then you will be able to perform the task that faster rate, because achieving parallel processing, the intent of actually doing a parallel processing for tiny simple repeatable tasks, you require GPU. So in a system, CPU and GPU can coordinate each other. One act like a manager. In our case, like a CPU act like a manager. GPU are like a specialized skilled person. So CPU handing off the work to the GPU. GPU does parallel processing and then returns the result to the CPU. Does it make sense? That's why you know high performance can be achieved by the combination of CPU and GPUs. So if you have more cores, then better for heavy multitasking. gaming, video editing, AI tasks are required this nature of system architecture. If you are already started working on a Colab, leveraging the Colab facility supplied by the Google, you will be able to see a runtime settings, right? So change runtime, basically runtime type basically tells you like whether your application requires a CPU or GPU or TPUs and all. So right, CPU is like a straightforward, but all the CPU functions, if you make it run into the GPU, you have some software programmatic changes to convert CPU statements into the GPU statements. But otherwise, this is like a simple concept illustrate like what is meant by CPU, GPU, and when to use what and all. I think go on better, you know log into the Colab and then started actually doing certain practices, right? So and then make sure that you are actually selecting the right processing unit for your application. Let me ask you one thing. Why GPUs is greater for AI? Okay, so we all know that CPUs are the sequential. CPUs have like cores are like very limited. When you have like a core, one core for one task. So if you have like more cores, that you will be doing like a more tasks in parallel. So right, but intent of CPU is basically general purpose. Loading the operating system, execute the operating system applications. That short. But by nature is like in a sequence, but some parallelism can be achieved through the your cores. Okay, now let's look at that specialized way of doing things in GPUs, right? In GPU, basically GPUs comes with like many specialized cores which handles like a small task, repeatable tasks, but more effectively, right? When you have like more cores, like more parallelism can be achieved using that processing unit. In our cases, like a GPU has more cores, so it handles more, handles small tasks in simultaneously like through parallelism, correct? So the reason I'm saying this all because when you are dealing with the AI, we have like a data sets. Dealing with the data set is like huge, very huge, right? Not just only look at a text data, but there is like imaging data, video data, and all, right? These data requires like matrix multiplications, like a, you are handling what you can call it as like that huge amount of data, isn't it? So then how you're going to do that, right? Matrix multiplications, the convolutions, and multiplying the gained grid of numbers using matrix operations, right? So precisely in the deep learning, the nature of the data and then the way you do math with the data is pretty high. It requires a lot of processing power. That is the reason where you talk about like you require like more processing unit, more powerful processing unit is known as GPUs, TPUs, that short. Okay, when you say GPUs, the core of the GPUs, like you have like a 10x, 100x compared to the CPU. That means like pretty faster than CPUs. Okay, the intent is again, yeah. So main focus for the CPUs are for general purpose CPUs, but GPUs for the gamings, videos, and modeling. That short. So I hope it clears that like why GPU is like a greater for artificial intelligence and machine learning. Training and learning, short of like an application case. In summary, CPU means central processing unit, GPU means graphics processing unit. Okay, CPU good for serial processing, and GPU good for parallel processing. General purpose sequential execution. What meant by the CPU, intent for the graphics, processing unit GPU. Basically, like parallel processing, a repetitive small tiny task can be done in parallel. So throughput is so many tasks at once, right? So that means like a throughput from the GPU is like high. That's the performance perspective. Okay, GPU handles graphics and videos, 3D modeling, AI, deep learning, simulations. Those kind of requirement you would need GPUs. Other hand, CPUs like running operating system applications, databases. That short. So if you look at the workflow point of view, like CPU loads the data set with as per as AI concern. CPU loads the data set, organize in batches, set up the model, things like that. Is being carried out by the CPU. Once that is done, the CPU handing over control to the GPU. GPU crutches the heavy math, right? Matrix multiplication, convolution, those kind of things done by the GPU, because GPU have like plenty of cores, and then have a capability of actually handling repeated things in parallel, right? So that's a GPU does. Once a GPU does, what happens, like a CPU takes the results from the GPU and then updates the parameters and keep things moving. So this is how I think AI leveraging CPU and GPU cores within a system for AI modeling, right? So one thing very sure, like what portion that you have to run it in CPU, what portion you are going to run in GPU. So if any piece of code that you would want it to run in GPU, what you do, like there is a software change required. So it requires additional software program to convert CPU functions into GPU functions for parallel execution. Okay, you got the point. So this this a set of pointers which basically like tells you how you are actually leveraging CPUs and GPUs in the context of AI/ML, data modeling for training and learning. You might have overheard like Intel, right? Core i3 core, i5, i7, or AMD in the chart. So some of the core manufacturers like Qualcomm, Intel, Renesas, ARM, ST Microelectronics, Texas Instrumentation, advanced micro devices like an AMD. Whereas for GPUs, we have AMD, Intel, NVIDIA, Gigabits, EVGA, MIC, right? NVIDIA Quad, Redon HD, Intel Arc, and so on. Folks, visit us at our YouTube channel, Maths Bridge. I'm very happy to inform you all that our learning corpus is getting increased day by day by adding a new content to it. Thanks for all who are actually being part of it. Uh, Please feel free to subscribe the channel if you have not. Thank you for all your support, guys. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Happy learning. Thank you. Stay tuned to upcoming sessions.